What up, everyone? This is LeetCode problem 13, Roman to integer. So we have Roman numerals represented by 7 different symbols: I, V, X, L, C, D, and M, and right. These are the symbols, these are the values they represent, right? Just basic Roman numeral stuff. For example, 2 is written as II. We add the two ones together. 12 is written as XII, which is simply X plus II, etc. Uh, really, really, the most important thing to remember, um, in terms of when you look at these numbers, right, in terms of how we mathematically convert Roman integers, or yeah, Roman numerals into integers, is that when the next value is greater than the current value, we don't want to add them together. We want to subtract the current value and then add the next value. For example, right? I'm just going to use an example here. When we have something like 4, we write it as IV, right? Well, in this case, what we're essentially doing is we're subtracting 1 and adding 5 to get 4, right? Whereas if we have something like 6, we're just adding 1 and adding 5 to get 6, right? So, whoops, give me a second. So, when we're at a specific number, if when we're at a specific Roman numeral, if the next Roman numeral we encounter is greater in value, we're gonna subtract the current numeral we're on, or the value, and we're gonna add the next value. For example, if we have something like IX, which would be 9, well, the second Roman numeral encounter is greater than the first in terms of value, so we're gonna subtract 1 and add 10, right? And that's how we get 9 from the Roman numerals IX. Okay? Keep that in mind. So, this problem can be a bit tricky because if you try and do it like in a brute force approach, you have to just account for the edge cases, and that can throw you off. So a hash map actually is super helpful for this specific problem because you can handle edge cases much more easily since you can refer to a specific value given a specific Roman numeral, right? So we're gonna say this. Well, first of all, actually, let me just do this much faster. I don't want to just manually populate this hash map and bore you. So here's our hash map, okay, of our Roman numerals and their corresponding value. Okay, now what we're given for this problem is a Roman numeral, but it's a string, right? So we're gonna have to iterate over what? The characters, okay? We're gonna go character by character. So we're gonna say, and given this Roman numeral, we have to convert it to an integer. So initially our integer is 0, right? Because we haven't iterated over the Roman numerals yet. At the end, though, this total is going to be the conversion number, right? If we have something like II, this total should return 2, okay? Make sense? Okay. So now this is where the bulk of our work is going to happen. So we're going to iterate over this string. I'm going to say for index in range of the length of s, okay? Because we're going to iterate, we're going to start with 0, then 1 and 2, right? Up until, not until the length of s, but until, because again, this is like saying, right, for index 0, right, index is less than the length of s. So we're not including the length of s, but it's up to the length of s, if that makes sense, okay? Right, just explaining that in case you maybe come from a different programming background, like using Java or C++ or whatever. So we're gonna say if the next index is less than the length of s, meaning we're not out of bounds, and the the given actual Roman numeral is less than the next one. So we're going to say Roman map S of index is less than Roman map S of index plus 1. In that case, we're going to subtract from the total whatever we're currently at. Okay, I'll explain this in case you're not picking up. So what we're saying is, we might have something like this, right? Let's say we're at the 0th index, which would be I. If the index to the if we increase the index by 1 and we're not out of bounds yet, that means we can look at this v, right? Because it exists, we're not out of bounds in terms of our indexes. Okay, so we'd enter this if statement, but we have to check this right here. What we're saying is this current index I less than the next index Roman numeral, which would be v? Yes, it is, right? Because I is equal to, because this would be Roman s at index 0, which would be I. Well, Roman map at I would return 1. So we're saying is 1 less than the Roman map s of index plus 1, which would be v. Was Roman map of v, what would that be? 5. We're saying is 1 less than 5? Yes, it is. So from this total, we're going to subtract the current index, which would be this Roman numeral I, right? So, which would make sense, right? Because remember what I showed you earlier? If we're at a current Roman numeral and the next Roman numeral is greater, we're subtracting the current Roman numeral, right? And then adding the next one, right? That's how we get 4. We have to subtract the current Roman numeral, and then at the next one we just add the entire thing, which would be 5, and -1 plus 5 is 4, which would make sense, right? Because that's what this Roman numeral represents. It represents 4. Okay. So now, what if that's not the case? Well, if that's not the case, that means the next Roman numeral is not necessarily that means that the next Roman numeral is not necessarily greater. Okay, so in that case, we would just add the total, or we would add to the total the current Roman numeral that we're at. Okay, right? Because why? Because we might have something like this, vi, right? Well, v is not greater than, or v is not less than I, right? V is not less than I, right? So when we encounter this, which would be 5, we're just adding the entire thing, right? Now when we encounter the 1, we're adding the entire thing, okay? And that, what would that give us? That would give us 6, right? Which makes sense, right? Vi is 6, okay? So, yeah, this algorithm, not too complicated as long as you understand how we're using the hash map, right? And looking up our symbols to get our values. But I'll be honest, the first time I encountered this problem, it was a bit tricky. I tried to do it a brute force approach instead of using a hash map. And this hash map really simplifies this problem. So yeah, if you're stuck on this problem, you're probably like me trying to do it a brute force approach, and it just gets really messy trying to handle the edge cases. So I feel for you, but yeah, not. I mean, I'm gonna be honest. I find this problem a little bit stupid, but I think it's pretty common in interviews as far as I know. So yeah, it's still a good one to kind of understand and know how to solve in either case. But anyways, I hope this helped, and I'll see you in the next video.